Good afternoon. Today we talk the Google Ads budget optimization, a case study on budget allocation model for multi-product for Company 4E. And this is our group members.
Let's take a look at the content. First overview, we have background, problem statement, and objectives. Second, data source and parameter preparation. Third, optimization and scenario analysis. Finally, managerial insights and conclusion. Background. My company 4E is a global trading enterprise specialized in electrical products. To increase brand exposure and attract potential clients, we employ a multi-channel advertising strategy, introducing Google Ads in 2025 for the first time. Each month, I have to analyze the performance to adjust the 10,000 fixed monthly budget among 5 products. The goal is to maximize conversions while maintaining diversified sales growth. This study uses regression analysis to identify relationship between budget, clicks, and conversions, and apply optimization models to determine the most efficient budget allocation. Problem statement. Conversion and click efficiency vary widely across product lines, creating uncertainty in how and spending drives results. Without a data-driven method, budget allocation depends only on subjective judgment, risking inefficiency and inconsistent returns. The company must therefore maximize total conversion while ensuring balanced product growth, requiring a quantitative model to first define the relationship between advertising input and outcomes, and secondly, optimize allocation within the fixed budget. Objectives. Especially, it aims to answer first, what are the quantitative relationship between budget, clicks, and conversions? Second, how do conversion efficiencies differ across the 5 products? Third, how can the 10,000 monthly budget be optimally allocated based on the regression estimated constraints?
Part 2. Data source and parameter preparation. Raw data were collected from 4E companies' Google advertisement dashboard covering from May to October of 2025 for 5 major products A to E. The dataset includes the following key variables: budget, impression, click rate, cost per click, expense, conversion rate. These variables are chosen based on the marketing series and their expected direct impact on click and conversion volumes. Firstly, we performed a basic analysis on the raw data by month. It showed that inconsistent budget execution, poor cost control, and failure to fully utilize allocated funds. Highly volatile clicks and conversion numbers month over month. Secondly, data analysis by products indicates that severe performance disparities among products, with A and B significantly outperform. Inefficient result allocation persists on underperforming products, continue receiving budget without improvement. For further analysis, we should determine the parameters to be selected. The budget and the cost per click will affect the advertisement result. The primary decision variables are budget and cost per click. Optional dependent variables are including clicks, conversion rate. To select independent variables strong linked with the smallest p-value of dependent variables. We performed regression analysis on budget, cost per click, various clicks, conversion, and conversion rate. Regression analysis on conversion, various budget, and cost per click shows budget is marginally significant impact on conversions, and cost per click no significant impact. Regression analysis on conversion rate, various budget, and cost per click shows budget and cost per click have no significant impact on conversion rate. Regression analysis on click versus budget and cost per click shows budget positively influences clicks at significant levels, so we select the click as the dependent variables.
Optimization and scenario analysis. Linear programming optimization. Click-based constraint model is used to maximize expected conversions. Decision variables including x1 to 5. It means the budget allocation percentage for product A to E. And the objective function is to maximize Z, where AI is mean click from the historical data of the 6 months, as you can see in the screen. Constraints. So as you can see, we set some constraints here and we get the optimum. So the output confirmed that the solution reached the optimum. In this way, we're using the linear programming and you can see the results. Results show that as for the budget, product A is 35%, B is 20%, C is 25%, and D and E is 10%. Only B within the range and others are on upon limit or at lower limit. To further analyze this data, here we have a pie chart, optimum budget allocation proportions. So the result indicate, and you can see from the screen, the objective value Z now equals to about 265.9, indicates the expected conversions given this allocation. So when we take a look at the sensitive analysis from solver report, we can see that we have shadow, price, allowance increase, and allowance decrease. So for the first one, we have the interpretation. If we reduce the budget by 1,500, it would reduce the objective function by approximate 34.05 units. That is 0.0227 plus 1,500. And then the next one, allocation 35%. The shadow price is 18 and the allowance decreases 18. So if Z drops by 18 and A reduced 1%. Yeah, it is obvious that there is a negative 1 here, and this negative sensitivity, relaxing the budget by 1 unit, decrease overall conversion by 1. Since product B is the company's flagship product, and converting the inquiry into actual orders much easier than A and C, so we cannot simply reduce the proportion of B. Although the data suggests that B should be lowered, we will not make any adjustment here, but in the future, we will continue to monitor and how this factor will impact the company's overall performance. For the scenario analysis, if we increase the budget by 10 or 20%, you can see that the expected Z conversion will increase by separately 8.5% and 17%. And the most additional budget should go to A or B or C. The sensitive report shows an allowance increase of 0, and previous analysis indicates the limit has already been reached. Therefore, no budget increase is needed at this stage, and it would not yield proportional or higher conversion returns. Yeah, let's take a look at this table, and you can see that if it is decreased by 15%, it is obviously decreased the Z by almost 34%.
By integrating regression analysis and linear programming with a click-based constraint framework, the study provides a quantitative data-driven approach for monthly Google Ads budget allocation. But there are still lots of core challenges. For example, Google's real-time auction system causes constant change in key metrics, which leads to a fluctuating click price. Historical conversion efficiencies become less accurate over time. A fixed model cannot adapt to evolving market conditions automatically. So, how can we lower these risks? First, we should implement a monthly or quarterly review cycle to update the regression model with the latest performance data. Secondly, we can adjust the model's constraints flexibly based on some situations, such as new product launches or shift in company strategy, changes in seasonal demand. Currently, our model only focuses on product-level optimization. However, there is significant potential to enhance prioritization by factoring in country-specific performance. And the next step, we will layer this into the model as regional data matures. Thank you.